Hi. Hello. So today I'm going to demonstrate load balancing on the Loongson Mini PC with the open source software LoXILB. Yeah. So again, for the network collection, this is a Loongson Mini PC with LoongFire open source firewall, and the red cable is to the upstream internet collection, and the green cable is to this router in bridge mode, and the orange cable connected to this guy, this iMac, and so this guy now will have an internet connection, and but in this demo we are also setting up a web server on this iMac. So when this iMac has an internet connection, so this guy will send a HTTP request to through this red cable, and then this mini PC will load balancing the HTTP request through this green cable to the Wi-Fi router, and then to this iMac web server. So that's how it works, and we are going to set it up. So again, we manage the firewall through this web UI, and so we can have just double check if we have internet connection, right? We should have internet connection because we are connected to the mini PC router, and
have you ever seen the magic glasses?
See? So it has the internet connection. And now we are going to, because usually for a traditional firewall, you would set up a port forward to route your ingress traffic to your local web server. Like traditionally, you would use the port forward NAT, and then you specify your local web server IP address, and then you specify the protocol like TCP. Then you specify your local web server listening port, right? For example, if I want to set up the so this is my iMac here. I have the web server, and I have the local web server IP address in the green network, and then I have a web server listening with the Nginx on port 80, right? So this is my local web server running on this iMac. And then when we set up the port forward, we would use TCP port 80, and then we would specify the local web server IP address. So this is how the typical firewall port forward work. Like when you want to host your web services in your local home network. Yeah, and also you have the same proxy, XDP acceleration for same flood protection, right? So this is the benefit of using port forward. But in this demo, we are going to use the, let's go to the open SSH session of the firewall. And I'm going to use the LoXILB project. That is for load balancing, okay? Maybe we can take a look at the web, the project GitHub repo, XILB IO. So that's the project GitHub repo and LoXILB. So the reason I choose this project is because it is eBPF based cloud native load balancer. And so the main goal of this project is for Kubernetes cloud native, but it also works fine for a traditional firewall or router. Yeah, so this is the project web page, and I compiled this project in the LoongFire open source release. And actually, I do come across few problems, but yeah, there is some issues here. Let's see, closed, and yeah, like here. We have some issue specifically for LoongFire, for LoongArch, Loongson LoongArch platform. Yeah, but anyway, let's just go to the demo. And so here is how we set up the okay, first let's do a test. So this is our test machine. We send the HTTP request to the router. So if we do this guy, and so this is our router public IP address, and we send the HTTP request to the port 80, and right now it doesn't work because I have not set up the load balancer, right? So now let's go set up the load balancer with the LoXILB. So this is how we set it up. LoXI, CMD, create. So notice the syntax here. We use this command. So this command is going to talk to the LoXILB and create. LB is load balancer, and that's the listening public IP address on the router, on the firewall. And this is TCP listening port, the external listening port, and the local server listening port, and the endpoints is the local web server IP address, the IMAC address, which is 9.9. Okay, so let's create it. So it now says success. And then if we come here from the, to this client, now let's send a curl request, and we get a HTTP response, right? And it works. So let's send again, right? We got a HTTP 200 OK with the web content, right? So, and yeah, so here is how you how we start up the, like now we can delete the web server, the load balancer. yeah, so this is how we delete it. Let's delete it. Succeeded. Now we come to here and we want to send the request again. So it doesn't work, right? Yeah, it's simple. Load balancer. We can also actually it has a lot of features, and we can check the command -h create LB -h. So it will list the syntax how you can create load balancer. See, it has I used this sample, and the last thing that it has C4 NAT, which is you can on the server side you can translate the source IP, the client IP, to your local router IP address, and it also has a full proxy for HTTP layer 7 proxy, and yeah, it actually has so here is the load balancing algorithm you can choose. Yeah, so this is a nice project using the Revolution eBPF technology. And so here is our LoXLB daemon that is listening. Okay, and we can also so we have BPF program, the LoXLB BPF program loaded. So those are the eBPF program hooked in the TC layer, right? And we can also check use this TC filter show dev green 0 ingress. So it will show the eBPF TC program attached to the green interface, right? So there is a little bug here, and see in this BPF toolnet, we do not see the TC program attached to. There's no green 0 interface here. There's no green interface, neither red 0 interface. So that's not a problem because for some reason the BPF toolnet does not show the correct TC BPF program for the interface. But we can use the TC filter to show the actual BPF program here. Yeah. So here is how I started it up. Started the LoXLB up. So it's the setting is here. IP LoXLB setting. So right now, we see label LoXLB on. Right now it's running, but if we want to turn it off, we can turn it off. Then we can stop it. Stop. Okay. So the daemon is stopped. If we run run this LO again, we will fail to connect to the daemon. cmd create LB. Yeah, anyway, so yeah, the daemon is stopped. And okay, cmd. So if we want to create it again, we will fail because the daemon LoXILB daemon already stopped. So you will get an error post. Okay, but now if we can start it up, let's enable it, and then let's start it up. Okay, so it's started okay. Now here is the log. Here is a log. We can check LoXILB LoongFire. So this is the startup log, and yes, here is the startup log. You can check red 0, green 0. So yeah, it shows the startup log, and we can also use TC filter, show ingress, and it is there. And now we can use this guy to check there's no load balancer setup configuration. So we wanna create the configuration again. Okay, succeed. And now let's go to our client. We curl. Wait. Oh yeah. See, I set up the wrong IP address here. That's why it doesn't work. See here, I used the wrong public IP address. Let's delete it. Let's delete it. Oh, oops. Yeah, I should LOXI cmd delete LB. Let's delete this guy. Okay, delete it. Let's recreate it, and let's use the right IP address. Okay, we can also get LB. So we have the right external IP. Okay, so now it should work. Let's look at our client, and clear, curl, right? It works. And so what else I want to show you? Let me think. And yeah, you can also save actually. LXI cmd save -a, I think. Yeah, so you can save your configuration when next time when it start up, and you will have the previous configuration. Yeah, so I think this is a cool, the LoXILB is a cool load balancer with eBPF technology. And but one thing it doesn't work is it does not work with the XTP SIM proxy acceleration, because the SIM proxy, the TC layer is bypassed by the XTP. Let me show you a network diagram. Linux net filter network diagram. So yeah, so this is the network diagram. let's make it bigger so we can look. Okay, bigger. Okay. So here is the XDP, right? So here is the XDP layer, and the TC layer is so the TC layer is after the AF packet. Too bad this diagram didn't draw the TC layer, but it is after. So the XDP is the first layer. The TC is after XDP. When we use the XDP SIM proxy, the XDP will process the SIM packet, and then it will use the let filter IP table to set up to use the SIM IP table SIM proxy. But the TC layer will not see this the SIM packet for the XDP, so the SIM packet is invisible to the TC layer, and that's why the SIM proxy, XDP SIM proxy, will not work for the TC layer, and so that's one thing we need to keep in mind. Actually, I opened up like GitHub. Yeah, we have a request here, issue. So I filed the enhancement request, SIM proxy, this guy. Yeah. So I will send up a enhancement request to have LoXILB to support SIM proxy in the TC layer. So that would be cool if this can be implemented. And yeah, that's what I want to show you today for the LoXILB on the Loongson open source firewall, LoongFire. Thanks for watching.